Hello, 8th graders. I'm going to read the article that Mr. Carlender posted today. Today is January 6th, 2021, and this has to do with desalination. I actually worked on a project about this not too many years ago. We were talking about it a little bit in class yesterday. It's pretty interesting. So all you're going to do is write a summary in your own words. I'm going to read it, and I will help you determine some of the most important points. Hand it in, and that is your assignment for science today. We see the directions right here, as I just read to you. And remember, complete sentences. They're your friend. They'll be your friend forever. All right, the key question. Why don't we get our drinking water from the ocean by taking the salt out of seawater? Peter Glick, president of the Pacific Institute, distills an answer. That's kind of like a play on word. If you distill something, like distilling would be like taking the salt out of the water. Ha ha ha. Scientists think they're funny. All right. Starting right here. Even with all the water in Earth's oceans, we satisfy less than 0.5% of human water needs with desalinated water. We currently use on the order of 960 cubic miles, or 4,000 cubic kilometers, of fresh water a year, and overall, there's enough water to go around. There is increasing regional scarcity, though. Regional scarcity means in certain places, there's less water. Think about the water map Mr. Carlender showed us, how in some places there was lots, some places there wasn't. So why don't we desalinate more to alleviate shortages and growing water conflicts? The problem is that the desalination of water requires a lot of energy. Salt dissolves very easily in water, forming strong chemical bonds, and those bonds are difficult to break. Energy and the technology to desalinate water are both expensive, and this means that desalinating water can be pretty costly. So here are two key reasons right here. It requires a lot of energy, and the technology is very expensive. Right here. It's hard to put an exact dollar figure on desalination. This number varies wildly from place to place, based on labor and energy costs, land prices, financial agreements, and even the salt content of water. It can cost from just under $1 to well over $2 to produce 1 cubic meter of 264 gallons of desalted water from the ocean. That's about as much as 2 people in the U.S. typically go through in a day at a home. So that might be an important point. Like, it is expensive no matter what, but the cost varies based on resources where the process is happening. And I should stop for 1 second and just say, to desalinate water means to take the salt out of it. Just in case that wasn't obvious from the beginning part, I just want to state it very clearly. You cannot drink ocean water. It will make you sick. The salt will dehydrate you so bad, eventually you will die. You can't do it. So it is essential to take the salt out if we're going to use ocean water. But these are the reasons why we don't do that. All right here. But switch the source to a river or an aquifer, and the cost of a cubic meter of water can plummet to 10 to 20 cents, and farmers often pay far less. So 10 to 20 cents if you're taking the water from a river or aquifer, which is an underground water source. It's like tenfold. 10 cents versus $1 or $2. That's 10 times more expensive. That means it's still almost always cheaper to use local fresh water than to desalinate seawater. This price gap, however, is closing. For example, meeting growing demand by finding a new source of water or by building a new dam in a place like California could cost up to 60 cents per cubic meter of water. So they're saying that when we need more sources of fresh water, we then have to build access to it, and that can also be expensive. And sometimes these traditional means of harvesting water are no longer available. As such, this cost figure is expected to continue to rise, which is why California is now seriously considering desalination and why the city of Tampa, Florida, decided to build the biggest desalination plant in the U.S. So you can see why places like Tampa and California would need to do this, because the water source under Florida, there's a big aqueduct, I believe, under Florida. It is drying up. Populations in Florida are high. And as we know, the population of California is also incredibly high. And they've been facing droughts and fires. Those things cause issues with the water cycle. With their high population and lack of water, I wouldn't be surprised if California gets forced to go the route of desalination. My dog is snoring right now. All right. The International Desalination Association says that as of 2007, there were about 13,000 desalination plants operating around the world. They pumped out approximately 14.7 billion gallons of drinkable fresh water a day. A lot of these plants are in countries like Saudi Arabia, where energy from oil is cheap, but water is scarce. So how is energy used to separate salt from water? There are two basic methods for breaking down the bonds in salt water: thermal distillation and membrane separation. Thermal distillation involves heat. Boiling water turns it into a vapor, leaving the salt behind. It is collected and condensed back into water by cooling it down. So it's steam, essentially. The most common type of membrane separation is called reverse osmosis. Seawater is forced through a semi-permeable membrane that separates salt from water. So basically it's forced through like a fine mesh. Or like, think about like your colander you drain spaghetti in at home, but with much smaller holes. Because the technology typically requires less energy than thermal distillation, most new plants like Tampa's now use reverse osmosis. So I don't have a great way to describe this process. If you think of one, you come let me know, because I would really appreciate it. There are environmental costs of desalination as well. Sea life can get sucked into desalination plants, killing small ocean creatures like baby fish and plankton, upsetting the food chain. Also, there's the problem of what to do with the separated salt, which is left over as a very concentrated brine. Pumping this super salty water back into the ocean can harm local aquatic life. Reducing these impacts is possible, but it adds to the cost. So this is very important. These are more reasons why we don't use this process very much. It can really hurt sea life. And there's a product left over, and it's the super concentrated salt. And we don't know what to do with that when we have it left over. Despite the economic and environmental hurdles, desalination is becoming increasingly attractive as we run out of water from other sources. We are overpumping groundwater. We've already built more dams than we can afford economically and environmentally, and we have tapped nearly all of the accessible rivers. Far more must be done to use our existing water more efficiently, but with the world's population escalating and the water supply dwindling, the economic tide may soon turn in favor of desalination. So, despite the costs and the energy needed, we've already kind of overtaken from our freshwater sources. That's what this paragraph is telling us. We have more dams than we can afford, economically and environmentally. That means it doesn't just have to do with money. It has to do with the harm we do to the environment when we build dams, because building dams does impede the flow of the river. We see small dams in terms of like what beavers build in rivers and streams around here. But look up something like the Hoover Dam. That's a major, major establishment. The building of it and just its physical structure is definitely going to impact the environment. All right, your turn. I hope I gave you enough information. Write a few sentences, sum this all up. It is an interesting topic. I recognize I'm a nerd. But I hope you learned something. Anyway, have a great day, 8th graders. Talk to you soon.